Hi folks, let's talk a little bit about how we use Hasura at Hasura. Basically, I'm going to give you a brief idea about how Hasura powers the software stack at Hasura. So I'm Shahid and I'm an engineer at Hasura. Currently, I lead the engineering efforts on Hasura Pro and Hasura Cloud. So right now, what we use Hasura is primarily for Hasura Cloud. So Hasura Cloud is a managed service where we run Hasura for our customers, and we have deployments across multiple regions and multiple locations, multiple clouds around the globe. There are global deployments available. It's by default auto-scaled, highly available. There are zero downtime upgrades available, and even users can configure their environment variables and other things without any downtime at all. And we do offer Hasura Pro on Hasura Cloud, so that comes with a lot of value-added features like monitoring, analytics, and things around regression testing, allow listing, and so on, right? So when we built Hasura Cloud, we were sure that we are going to use Hasura to build Hasura Cloud, and we were trying out different architectures to figure out how we can best make use of the technology that we have built ourselves, right? So we are not only the proponents of Hasura, we are a strong user of Hasura ourselves, and this adds a lot of value to the kind of work we do. Basically, it gives us a feeling of how each of the users are using Hasura, and lets us make improvements from our own side. As a user of Hasura, we give a lot of feedback to the Hasura core team itself, right? So the first component I want to touch upon is the controller, which is the core of Hasura Cloud. So what the controller does is it is something that interacts with, it is something which controls the entire system, and it is the one which is responsible for creating multiple Hasura instances for each tenant on Hasura Cloud, managing the configuration for these instances, and everything around it, right? So the controller is something which is gonna manage the tenants, right? So at the core of the architecture, there is a Hasura instance running, which is powering the cloud, and which is of course powered by a Postgres database. And whenever a user comes into the Hasura Cloud dashboard or something, and then they try to create a Hasura Cloud instance for them, right? And this in turn results in a mutation. So what the controller is now doing is it's subscribing to the list of tenants from the Hasura instance that is powering cloud, and what it's doing is it's getting updates on when these tenants are created, and it is in turn making decisions on provisioning the infrastructure. So when a new tenant is created, deleted, or modified, the controller gets notified via GraphQL subscriptions, and it reconfigures the actual infrastructure to match with the current state that we need, right? Now all the state for the tenants, the Hasura Cloud instances, which region they belong to, what cloud they belong to, what is the configuration, everything is stored in the database, and the controller just subscribes to the relevant portion of this configuration. So without Hasura, what we would have done is we would have built the code for building this event stream, and then subscribe all the actions and all the real-time updates, all of that it has to come from the database itself, right? So then we would have written something over listen notify, Postgres listen notify, and then we would have written our own permission layer around it, and control access to each and every type of the configuration and tenant around it, right? But with Hasura, all of this becomes easy. We get an access controlled API into the relevant portion, and we get real-time subscriptions as well. So whenever something changes on the database, the controller gets notified automatically. So we don't want to consume events, but we want to consume the state. So that means the state of the system is stored in Hasura, and every component subscribed to the relevant state from the main Hasura instance. So this will this lets our components become stateless, and thereby not worrying about storing their state at all. Whenever any component needs to understand its it's gonna just it's gonna get it from the core Hasura instance. So another interesting thing that happens here is that whenever a new tenant is created on cloud, the controller is notified of that, and controller tries to create or realize that particular configuration. Now errors could happen, right? When the database URL might be wrong, something else, some configuration might be bad, and this needs to be notified back to the user. So what happens is the controller will identify these kind of errors, and it will make a mutation back to the core Hasura database, and the client, the dashboard will in turn be subscribing to these error messages, and it can show the error message on the UI. So when a new config is applied, the error message is asynchronously shown on the UI. So this is a nice pattern. We'll come back to this. So everything is kind of revolving around the client making an action, and then that is resulting in some event somewhere, somebody subscribing to the state, and then some actual configuration is changed, right? So for storing the configuration also, we make use of a Hasura instance. So the secrets are not directly stored in the database. Rather, when a user makes a mutation to the Hasura instance, it is passed on to an action, and an action handler will handle the actual secrets and stores it in a secure secret store, in an encrypted secret store. So there is a Hasura action which is controlling all interactions for reading and writing this secret store, and all transactions are secured and scoped only to the tenant owners through Hasura permissions and the permission set on the action handler. So the next component that we have built on Hasura Cloud is the gateway, and gateway handles the routing for all of the tenants in Hasura Cloud. So for each user creating a GraphQL API on Hasura Cloud, we assign them a unique domain. So something like my GraphQL API.hasura.app, and the gateway itself needs to know that which tenants belong to which domains belong to what tenant, and which Hasura instance it should actually direct the traffic to. Now this information itself is again stored in a database powered by Hasura, and what happens is when a user is creating a tenant or modifying their application URL, that is in turn changing some values in tables, and the gateway is actually subscribing to this configuration, right? So gateway subscribes to the configuration, what are the tenants that are applicable to this particular gateway, and it gets those information via GraphQL subscription. Now whenever something changes, the gateway is again notified via subscriptions, and the gateway reconfigures itself to apply this new configuration. So now what happens is that some request comes from the public internet, and the gateway knows exactly which Hasura instance to load back to send this information to. So this is basically how the internal how the gateway architecture is, and everything coming from the user action it is going into the database, and then that is in turn triggering an effect in the end components, but all in a stateless manner. The gateway itself doesn't store any state. Whenever it's starting up, it tries to execute a subscription, and it looks up the actual configuration from the configured Hasura instance. So the next part of Hasura Cloud is metrics and analytics, right? And this is basically what we offer currently as Hasura Pro. Now this is a pretty interesting piece. Basically all the Hasura instances running on cloud are generating various logs and metrics, and all of these are passed through our metrics processing system, and in turn ingested into a database, Postgres database, again powered by Hasura. So all of this information is coming into this Postgres database, and this is processed and aggregated and made available in a format which the Hasura console and other components can actually subscribe to. So the actual component is subscribing to values from this particular table, and it's exposed as a GraphQL API, of course, and the Hasura console or the end users themselves use the GraphQL API to build their own tools. So on the Hasura Pro dashboard, we give users insights into what is the number of requests per second that is happening on the system right now, how many errors happened over the last given time, what is the percentage of error, what is the error rate. All this information is derived from the metrics originating from the Hasura instance, and it is processed and saved into a DB and finally shown on the dashboard by using GraphQL APIs over the database. Now, we use a lot of Postgres functions and views to aggregate and restructure the data to make it into a format that is easy to understand and easy to use on the console. So we again use a lot of permissions and relationships, etc. here to build the right kind of GraphQL API we want and expose it to the right kind of users. So the next component we have is for feature gating and usage limits. So this technically means certain limits that we have put on the free tier, or the kind of usage limits that we have put for each kind of user. And what this does is it effectively lets you controls your interactions with the database. So the permissions on the database tables are controlled. The permissions are set to control inserts into the database tables. For example, if we have a limit on the number of rate limiting rules that you can have, that is again set as a permission rule on that particular table. So the GraphQL API which you use to create the rate limit rules will restrict inserts if the number has been hit already. So we make use of Hasura permission operators like _exists and everything around it to make this possible. So feature gating is again done using like this. If a particular user is not subscribed to the rate limiting plan or something around it, we control access to that itself using Hasura permissions. So this entire thing becomes a neat model in which all our business logic and everything is modeled within Hasura itself. We don't need to build an entire system separately where all of this business logic is handled. We get a bird's eye view of what is allowed and what is not allowed, and what is possible and what is not possible, by looking at how the permissions and the tables and everything is configured on the Hasura instance itself. This in turn is what we have always we have always put together as the three-factor app pattern, where essentially user makes a mutation, events are triggered, or subscribers are notified, and here our components are all stateless subscribers who subscribe to each of the particular information that they are concerned about. And then we build reconciliation loop to achieve the desired state, where each component has its own logic to observe the current state and to get the desired state from the actual source of truth, and execute actions to achieve that desired state. And whenever this loop is complete, each and every cycle, the current status of that execution is returned back to the initial data store as mutations, right? In this case, because we are using a GraphQL API, it's written back as mutations. Now there might be other consumers on the other end, like the dashboard or any other kind of visualization tool, or a user notification mechanism which is already listening to this status being written back. Now at the moment they are written back, those other subscribers are notified, right? Because they are running a real-time subscription, and all of them will be notified. So this is the kind of pattern that we are following everywhere in all the kind of applications that we are building. And here we went ahead with subscriptions instead of event triggers, because subscriptions are more flexible to actually obtain the information based on what is being demanded, right? Because the end effector effectively knows what is the information that it needs, and it can pull the information from the server, from the data store. If in the case of event triggers, we might need to know the addresses and everything about the end effectors, but here we don't need to know any of that. The end effector itself will subscribe and understand the actual data that it needs for its working. So this is a huge plus in making all the services and all the components stateless, so that they can just focus on the business logic it needs to perform, right? For example, the controller that we mentioned, the controller only needs to have the logic of observing the current infrastructure state and getting the infrastructure to the desired state as observed from the data store. So this is an immense improvement in our build times and in our engineering efforts, where we can just focus on what each component should actually be doing and not worrying about how it is storing the data, how it is storing the current state, where it is storing the current state, making that service stateful, and even passing messages around, right? That is very important when you have like a microservices architecture and we have a lot of components interacting with each other. So everybody kind of writes their status back to the Hasura database, right? So back to the database via Hasura mutations, and everybody else who wants to know about the status is subscribing to that particular relevant portion of the data. So everything becomes just easier, where each component is just concerned about itself, and the interactions are kind of driven through mutations and subscriptions, message passing around between different services. For example, when a new tenant is created, the actual action is just coming from the dashboard, which is a mutation, and the controller gets notified via subscription. Controller provisions infrastructure, the gateway gets notified via subscription, again it configures the routing and everything required for that, and all of this writes the status back to the database, and again the dashboard is notified. The notification is sent to the database via a GraphQL subscription. So everything kind of fits together into this three-factor pattern, and this is what enables us to build awesome products in fast turnaround times. So that's pretty much about what I wanted to mention about how we use Hasura at Hasura, and thanks a lot for tuning in, and thank you for your time.